So here's the latest and greatest 3D printed pulse motor I'm working on. So I tried making a rotor one other time out of a filament spool, and it didn't work out very well. So I'm going to try it again though. So I 3D printed these inserts, as you can see in there, with enough. These are 22.2 millimeter holes for the, what are they, 608 bearings. I also created these braces that will sit like this, and a screw will go in there, and a bunch of, there'll be 4 of these, and a bunch of magnets will go around there. Actually, just 4. But the reason why I'm making this video is I want to show you I'm going to try something that I've always wanted to try, and that is doing heated inserts. So heating the insert, pushing it down inside there, and that's what I'm going to do with the 2 top holes here and the 2 bottom holes for the screws that'll go in there like that, and then the larger hole on either side like so for the gotta make the hole a little bit bigger, because in my research I saw that you need to make the hole as big as the beginning part of the insert, as you can see there. And then when you heat it up, it'll you push it in and it grabs. I've always wanted to try that. And so I'm going to try it with these. And I want to do a test first. So I ordered special soldering iron inserts for your basic soldering iron. I'm going to try this without the inserts. They haven't come in yet. So stay tuned and I'll show you. So I have a TS100 soldering iron for doing all of my basic soldering, but I also have some of these, $9 ones that you get from Radio Shack, or that you used to get from Radio Shack. In fact, I think this is a Radio Shack. Anyway, you should be able to just put it on top of here like this and have it heat up, and then press it down in there. I don't think I've had this. I don't think this is hot enough yet. I don't know how to figure out if it's hot enough. Let me. Oh, it's getting there. It's getting there. So let's see. Maybe if I just keep it on here. I know pushing it down straight is supposed to be the big deal. Let me pause this and I'll bring you back when it's starting to work. I think it's starting to work. Yeah, there it goes. So actually that wasn't too bad. That wasn't too bad. Now let's see if come on, sit over there. Let's see if the screw goes in, which it should. I mean, I didn't press that hard. Come on. Yeah. It's not the straightest thing in the world. So I'll have to figure out a way to, here, let me see if I can straighten it out just right here like this. There we go. I don't think I straightened it out, but let's see. Yeah, that's not too bad. That's pretty straight. Now, I don't know how tight that's going to be, but I'm going to put one on this end, one on that end, And the one in the middle, the one that's going to hold the magnets on, the most important one, I'm going to put one on either end, and I have these long screws that will go all the way through to both sides, and that should lock it in there. Anyway, yeah, this is the latest and greatest thing, so stay tuned for that. So I saw a YouTuber. He made a kind of like a drill press for his soldering iron, which would then in fact keep it straight up and down. What I could also do is I could just print out a guide. And I realized that I've got different sizes of these inserts, and that if I want one on both ends here, I have to use the smaller of the two, or I can use a small one and then a medium size one, as you can see, because they will meet kind of in the middle. I could do that, or I could just do two small ones, because two medium ones will be too close together. Yeah, I got to figure out a way to get this nice and straight. What I could do is I could heat it up with the soldering iron and then screw this in really quick and push it down, but then this thing will absorb a lot of the heat out of the... I could just try and press fit it like this without even heating it up. No, that'll be dumb. Yeah, I'm gonna have to figure out how I can do it straight, because I don't want to get it all messed up. All right, stay tuned, guys. So as Jimmy DiResta always says, you go to school on the first one. So yeah, the first ones did not come out great. But then I got to this third one and I figured it out. You heat it up till it starts to move and then press it in on this marble top and it goes in beautifully straight. Hey? Yep. First one you go to school, and I decided that I'm not going to do them on both ends. I'm only going to do it on one end and then just put it in from the opposite end, which will pull this way, and the magnets will... And actually, in order to do that, I have to go all the way through and unblock the plastic, because the plastic is blocking it. Anyway, first one you go to school on, by at least the third one you get it. Stay tuned. All right, guys, welcome back. So I've created this test rig using a VCR bearing, a bifilar coil to test different circuits and different coils. Right now, there's a very weak metal core in there. I've since made a new one, which is much heavier and way more magnetic. I mean, way more attractive. Whereas this guy is only attractive on one side. This guy's all the way through. So I'm going to test a few things out. It's funny because I've been, and I also, if you guys are looking for an extremely well-made but very inexpensive Bedini SSG circuit, if you go on eBay, you'll see a ton of them on there, and they're really expensive. They're like 50, 60, 70, 80, couple of $100 for a single little circuit. This thing was under $20. Now, I haven't tested it yet, but I'm about to do that now. But first, I want to test running this with an air core versus running it with this solid iron core. And I think we all know that running it with an iron core makes it run much better. And it's funny because I've been playing with Chat GPT. I'm sure you guys have heard of it. And I've been asking it a lot. It's actually my go-to search engine. I don't even mess um, with Google anymore. I've been asking it a lot of different questions about pulse motors and magnetic motors, and we've had some really wild a couple hour long conversations, if you will, on these different concepts. And I recently asked it about when you wind a Bedini coil, and I specifically said Bedini coil. I said, is it better to wind it side by side, the two wires, or in a twisted pair configuration? And it came back and it told me the twisted pair because of magnetic coupling and higher output and the whole 9 yards. It was really interesting. So I'm going to try. I printed out some new coil housings. I'm going to try to do a twisted pair. It's kind of difficult to do that because you have to pull the wire out before you actually wind it and twist it, then rewind it on your winding spool so that you can wind it. I don't know of a way where I could set up. I'm thinking maybe trying to set up the rig with the two wires, pre-twist about, I don't know, a foot of it and start winding it that way and see if that'll work. But I think it'll slowly just unwind unless I put some kind of a, I don't know, twisting jig in between the coil and the two spools. I have to try to figure out how to do that. If you guys have any suggestions. Anyway, let me start this guy up and I'll bring you back. Yeah, so this is on an air core bifilar coil. I've got it tuned with the potentiometer. If I turn it up, it makes that squeaking sound. If I turn it just so the sound turns off, that's like, for me, that's, let me turn it up. There it is. Getting really good output. And of course, the video doesn't do it justice. It's spinning much faster than how it's showing on the video. And so let me slide. And of course, the second I slide that iron core in, you can really hear it speeding up. Makes a big difference. Let me tune it up a little bit. Whoa, it's funny. I just got shocked touching the, yeah, I got a little bit of a shock. There must be a short or something. Anyway, yeah, it runs much better with the iron core. And even though it's blinking on the camera, I have a solid output on the light. And what I want to do with this too is I want to charge up, I want to set up one bank of super caps over here and one bank over here, running it off the super caps, charging up the other super caps. Where are they? I have them around here somewhere. Here they are. I want to use this guy, which means I need to get another one because the one that I made, even though I made this enclosure, I bought this with the circuit board already attached, and it has 1, 2, 3, 4, 6 of them here. Yeah, it's really flying with that iron core. We're at 12.7 volts. All right, let me shut it down because I can't get the iron core out while it's still running. Yeah, see, that's a much better. Oh, that's this thing rocking. That's why it's making that noise. Much better than this one. The way I made this one was I measured out, I filled the cavity with the iron powder, excuse me, and then added the resin to it so that it was basically a solid mass of iron. Anyway, stay tuned. I want to hook this guy up. See if I can get it running. Stay tuned. And there's the new circuit. So that rattling sound is the looseness of the magnetic core. But it's working great. And this thing, I wanted to get one because I wanted to see, how much it would, if I could get one reasonable. And under 20 bucks is freaking fantastic. And it has a little pot on there. I can turn it all the way down. I can turn it all the way up. It really has it flying now. Let me turn it down. But yeah, solid output. That thing works freaking great. So this is the test rig I'm talking about, testing different circuits. 12.7 works fantastic. Of course, I want to put a better Bedini coil on there. Remember I was telling you I wanted to do a full-on twisted pair. I don't know how I'm going to do that though. If you've got a suggestion on how I can do it without unraveling the length of wire that I would need, then twisting it, then winding it back up, you know what I mean? There's got to be a way I can do it on the fly. Yeah, that works freaking great. Guy did a really good job putting that together. Everything is staying nice and cool. Yeah, not even warm to the touch. Iron core without an iron core. And if I put it in this way, it's really crazy because yeah, I can't put it in that way because I put the coil too close. I made the coil so that it locks in like that. I'm sorry, I made the core. So I have to put it in backwards. Doesn't seem to be much of a difference on the output, visually anyway. But again, I don't have it in the right way, and I don't want to. Let me hold on. Let me get something where I can hold it so it doesn't go flying in there. Let me grab some of these, turn it upside down. Yeah, when I get it closer like that, it really speeds it up. Huh, I forgot about that. Adding the magnets to it. Let me add Oh, let me add. Oh yeah, adding a magnet to the iron core definitely helps it to produce. Yeah, that's crazy. I mean, not crazy, it's common sense, but yeah, so iron core much better. Got to make the iron cores thicker so they don't rattle, or put some tape around it or something. But yeah, so this is a great circuit. I was really surprised. I mean, I wasn't surprised. It's a basic circuit. It's got all the components, but it's put together really nice. And I haven't forgotten about this guy, although I think I'm going to scrap that. I don't know. I think I want to get better magnets for the test rig. Slow down. But it's really nice because it's on this VCR bearing, which is really nice. But I think I want to just get some regular barrel magnets on there. The ones I have, the screws don't fit through there. Oh, wait a minute. I haven't tried those. I'll have to try those and see. All right. Stay tuned. Yeah, so that's when the iron core is in there the right way. When it's the closest to the magnets I could get it. I also have to figure out how to do it so that the magnets run super close to it and not have that bolt in the way on the end there. But there's a lot of vibration here, as you can hear. It's running really nice now. Really good output. Continually speeding up. I really want to get that other coil wound with the twisted pair. I think I can do it. I got a long enough driveway, but I don't want to have it hit the ground and scrape against it. I think my best bet would be to go to a field. Yeah, that's running really nice now. Even on camera, it looks good. All right, guys, stay tuned. All right, so I got it hooked up to the super caps. I have the charge port hooked up to it, and it's going up slowly. There it is. 74, 75. Charging at, or running at 12.7. I don't know why the neon light is not on. It's definitely charging. There's 3.8. Let me turn it up. So it works. Now it's starting to fly, but I'm interested in why the neon light. Let me unhook and see. There it goes. Okay, it must be because it's taking all of the back EMF and putting it here, whereas when I had the light bulb attached, it was not giving it all. Yeah, that makes sense. Now this thing can theoretically charge up to like 16 volts. I wonder if I can run it off of this. I'd have to charge. Oh, I know I can run it off of this, but not when it's at 4 volts. What I'd like to eventually do, maybe you guys can help me with this, is I want to, like I said, I want to get a second one of these, charge it up fully, have a second one that's maybe halfway charged, use the fully charged one to run this to charge up the second one, and then have some kind of a switching system that when the primary goes down to a certain voltage, like maybe 8 volts, it automatically flips it over and turns this into turns the charging battery in, or the charging bank into the primary. I would have to play with the circuitry though. Let me mess with this a little bit. That really sped it up. Oh, that slows it down. Let me get a halfway mark. Yeah, that thing is flying. And it's slowly going up. I suppose if I let this run for, I don't know, oops, let me turn it back up. If I let this run for, and if I change this and put it on the, if I turn the iron core around so that it was closer, probably in about 20 minutes maybe, it would have this thing fully charged up. I should see about charging some old batteries of mine up. Turn this into not only a test rig, but a battery charger. There we go. She's flying now, and she's sliding all over the place too. Got a lot of vibration. Gotta hold it down, otherwise it just wants to walk. Here we go, almost 5 volts. Let me turn it down a little bit. If I take that out, there's 5 volts. Let's put this in like this. I don't want to let it go though, because it'll go too far. Alright, let's throw it in there. Anyway, I wanted to show the practical application of this test rig. Use it to charge up batteries, use it to charge up supercat banks, but mostly for a test rig. So yeah, cool. Thanks for watching, guys.